Hey everybody, it's Shane from Norman S. Wright. Last week I talked about heat pump defrost cycle and why it's important. And so I want to continue on with that topic this week and talk about the difference between full defrost and net zero defrost systems. So let's get started. So as a reminder, heat pumps work by pulling heat from the outside air, even during cold weather. The outdoor coil can become much colder than the air around it, which causes frost to build up on the coil. During the defrost cycle, the heat pump temporarily switches from heating to cooling mode, which sends the hot refrigerant to the outdoor coil to melt the frost off the coils. So during defrost cycle, the heat pump is not supplying any heat to the space. That brings us to full defrost and net zero defrost systems. Let's slide this over and talk about them. Let's start with full defrost. This is the most common defrost strategy, and it's basically what I just described. During full defrost, the heat pump temporarily switches to cooling mode, sending warm refrigerant to the outdoor coil to melt the frost, and no heating is happening during this time. While it's defrosting, the heat pump is actively cooling the hot water loop, dropping the supply water temperature below the return water temperature. This decreased supply water may cause a noticeable dip in your indoor supply air temperatures. Now let's slide this over and look at net zero defrost. With net zero defrost, instead of both circuits going into cooling mode, the system staggers the defrost cycle. So one part of the system is defrosting while the other part continues to heat. The result is that you get supply and water return temperatures that are very close together, smaller temperature dips over a longer period of time, which is easier for the indoor equipment to adjust to, which results in a more comfortable experience overall. So let's bring both of these back on. If you graph the supply water and return water over time in a full defrost system, it'll kind of look like this. So this green line is the return water temperature, and the blue line is the supply water temperature, which dips below the return water temperature as we actively pull heat out during the defrost mode. But on the net zero defrost system, it'll look more like this. You'll have the dip in the supply water temperature for each defrost cycle, but they're staggered. So you have the same overall loss of heating capacity over a period of time, but the supply water only drops to about the same temperature as the return water because the circuits are offset. So let's move this over again. Net zero defrost is especially important in critical applications where consistent heat is a must, like hospitals or industrial facilities. Different types of heat pumps handle defrost differently. You'll typically see full defrost in air-to-air heat pumps, whereas air-to-water heat pumps often have net zero defrost, and VRV systems offer multi-circuit defrost, which is essentially net zero defrost. So let's pull all of this back on screen. That's full defrost versus net zero defrost and why it's important. If you have any questions or suggestions for future videos, put them in the comments below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.